Hi, in this video I'll discuss XLNet for text classification, how to perform pre-processing over text data which is unstructured, embedding and fine-tuning. Let's see how to discuss these topics. What is text classification with XLNet, how to pre-process custom data, how to create embedding using XLNet, how to fine-tune our model for sequence classification, evaluate XLNet and Python implementation of this XLNet. First and foremost, I'll discuss overview of this algorithm, which is generalized autoregressive pre-training model that overcomes the limitations of BERT masked language modeling. It uses a permutation-based approach to capturing bidirectional context used in semantic analysis. Its ability to model long-range dependency makes it effective for analyzing sentiments in long text. Okay, so if you do not have these clean text dataset evaluate modules in your library, you will have to install using this code. But I have already installed these libraries, so I'm not going to install these library here. I'm directly importing all the libraries, for example pandas, clean text, transformers and scikit-learn, evaluate random. This is the reason it's just importing everything here. So for a quick review, you can go back to this previous cells to run all these cells so that you can import and leveraging out of the box functionality of these libraries. So I will be using XLNet for my tokenization. I'll use sequence classification because my data set will have different classification there. I'll use training arguments, how to trainer will train my custom data set, will train my pre-trained model. I'll use pipeline to use different modules section of this pre-trained model. Let's see what are the different parts. You can see I have successfully imported all these modules, and let's pre-process our data. Before this, I'll have to import my data set here in this portal. For this, I'll use pandas read.csv library. So this library would be used for certain import purpose. So I have already imported emotion labels, emotion label test, emotion labels value, and you can go back here this portal. You can see this is already having all these CSV files. So you will have to import, you will have to keep all these emotions related CSV files in the same place in your notebook. Okay, now I'm going to run this cell so that I can import everything here. Let's see what's the ingredient of my trained data set here. So can you see it's showing everything here? Text and relevant labels are there, joy and other labels would be there. Okay, you want to see other label, for example I'm going to use tail, so this would be sadness and other labels are also there. For example, I want to set sample label, so I'm going to see the sadness. Okay, let's say I'm going to see 5 samples. Can you see joy, fear, sadness, angers? Okay, so these are most properly labels for my data set. Let's check for test data set. In a similar context, my text data set, their feedback is there and their relevant labels are there. You can see these labels are supervised, denoting supervised learning. So I'm going to define my validation files. This is also divided into 2 parts, text and label. So this would be text and labels, and therefore I'm going to import this part here. Let's concatenate everything here, train, test and validate everything here, and let's see the size of this data set. So I'm going to check size using the shape command. Can you see this shape command is not having a parenthesis? Okay, so now I'm having 7102 rows and 2 columns, which is sufficient for my data set. And I'm going to import this data set, going to check this this cell whether this data set is properly imported. Yes, it is now showing everything here. Now I'm going to clean my data set because it might have several other parts. For example, this is library. I'm going to use this preprocess library for my text data set. If you want to see the ingredient of this clean function, you just go back, run this cell, just run clean dot code underscore underscore code underscore underscore dot covariance names. You will see, you will find these pre-processing steps will be followed over the given columns. For example, normalizing white spaces, no line breaks, strip lines, and keeping fixed Unicode, and no URLs, no emails, no phone numbers, no digits, and replacing with punctuations, language, replace with numbers, replace with digits. So many other pre-processings are doing with a single part. For example, you do not know what is the ingredient of this clean. So what you will do, you can go back and just import this clean inspect data set and just run this cell. I'm going to uncomment this cell and going to run this cell so that I can see what's the ingredient part. Here you can see this is the email and this is the another thing. Can you see when I have run this cell, it says consisting clean text, so many other are showing here. So this was just illustration part. Don't need to dive right into the function itself. It's just performing several parts. Now I'm going to clean this data set and going to create a new column with this text clean name. This would be text and going to perform ASCII and ignore everything here. It's going to perform this value. Okay, I'm going to substitute every other values from the given text. For example, this is the relevant data set. Okay, let's see the data dot head first, which new column which we have created here. Can you see this data clean just we created? This column is having so many different things. Can you see this G is now small case and others ASCII values are embedded, UTF-8 is decoded now, and other things are done here. Now I'm going to replace this value with substitution function, and this would be our next part. Let's see what's the data head now. Can you see this data head is now having so many different values? Can you see now it's having clean data set. This @ is now missing. These symbols are not there. Emojis, I would say these emojis are just replaced there. Every other @ part is now just removed there. So in a single shot you can remove everything here. Now let's create the graph for my value counts, for my labels. Can you see my labels are fear, anger, joy, and sadness, which means only 4 labels are there. Those are defining these texts on the left hand side. So these classes are defined in a different way. So mostly I have fear category, then I'm having anger, then joy, and sadness. If you want to see another part for the same group, you want to group by, so you can group by these values as well. Can you see this is just group by and the sample is defining into the sample value. Let's see the data, and I'm going to show this data set. Can you see this data is also defining in a different labels? For example, anger, sadness, and other things are just defining there. Okay, now I want to see these labels are defining. So for example, if I want to see the labels now, can you see now these labels are in a different sections in a proper way. They are defined in a proper group. Okay, if you want to see, if you want to convert these, you will have to convert these classes in a label encoder. So what is the label encoder here? So I'm going to define this label encoder, and can you see in this diagram, for example, state are written in word format. So general, not specifically, they are written in nominal scale. You want to convert in a label encoding, so these are numerical values. Those are converting these words into numerical words. This is called label encoder. This is the responsibility of label encoder here. My class names, these are angers, fear, joy and sadness, are converted into integer numbers. This is how I can convert everything into a numerical part. Now let's see what other things I can go here. Once I know number of classes are 4, so I can define number of labels are 4, which means my classes are 4. Now I'm going to define my train test value into 80 and 20%, and this train test values are defined into 90% again and 10% for validation only. If I want to see the length which you've divided into this part, so I can check the length as well. So these train are having 4414 rows, these tests are having 1227, and test validation are having 491 rows only. Rest are divided into 3 parts. So I'm going to train this value for my train values. So these are defining into train underscore df. These are labels and these are test. So if you want to see the train df, so you can see this train df is now having these categories. Can you see these labels are defining into 3, 2, 0, 1 and so on. They are integer values and they are text clean values. These are text clean values as well. Okay, so text are having this splitted terms. In a similar way, I can define my test keywords as well. In a same way, my text and labels are defining into different context. Now I'm going to convert this data set. This is the numerical data set. I'm going to convert this data set into dictionary format, from dictionary format to data set there. So what is the dictionary? Why from dictionary? Let's see through an example. You are trying to, for example, I'm going to check the type of my train df. You will find this is dataset dot arrow underscore dataset dot dataset. What is the meaning of this term? This meaning I'm going to trying to convert the pandas data from frame, which is train df my variable, into Hugging Face dataset dot dataset, which is predefined dataset here. For example, from a dataset library, you want to import this dataset, which is predefined context of my Hugging website. So this is dictionary which I am defining. This is the dataset from my dictionary values. Now I am going to run this cell. For example, I want to check whether this dictionary is there. What is the type of this my dictionary? If you will check this value, you will find the type is dictionary only. But if you will check the type of dataset there, this would be dataset.arrow dot underscore dataset. This is what? This is the internal class used in for Hugging Face dataset library to handle dataset in an efficient memory mapped arrow format. This class is typically accessed through dataset.dataset, and you can go through with certain libraries. So I'm going to convert everything there. I'm going to convert dataset through dataset dictionary as well. Can you see? Now this is having train and test only. Now this is creating what? This is creating, I'm going to this one. So this is creating dataset dictionary in Hugging Face dataset library, which is useful for managing multiple dataset, for example train and test sets, in a structured way. If you want to see the ingredient of this dataset dictionary, you can go back here and just run this cell, and you can see this is now defining into trained values. So these are features, these are number of rows, these are features, and these are rows only. And now you want to see the create embedding. You will have to first tokenize this value, and this sentence piece library is useful. If it is already installed and still is showing error, throwing an error on the screen, you will have to upgrade your sentence.piece. So this would be the upgraded value. Tokenizer is what? Tokenizer is your predefined function which will be used from XLNet tokenizer and from pre-trained model which I am using here. This is based cased, means uppercase and lower case is different here, and this is base model, not the large or medium kind of model, and we will use throughout the project this model. Later on, once I have defined this tokenizer, I am going to parse this tokenizer to entire column. So can you see this text is going to parsing there, and this is going to parse this tokenizer function over the given column. Now I'm going to provide this data set dictionary to my tokenized function and going to define everything there. So this is now parsed, mapped everything there. Now here you can see we have already created the tokenized data set, and made ourselves familiar with dataset.dictionary. Now I can check this dataset tokenized dataset only. Can you see this is showing different values? If you want to see the first part of this train text, you can see the train text dot zero is having this effect. If I want to check first one, this is having this context. So this is the first ingredient of this value. And if I want to check the tokenized value, can you see this is the tokenized value which is converted into integer numbers, which is embedded eventually, because we cannot go with words. We will have to convert into numerical value for our ML learnings and deep learning models or any other training transformer models. So you will have to decode this one. If you will decode, you will can tokenizer.decode.5. you can see these are all padding here. If you want to decode other parts, for example, I want to decode, for example, 500. Can you see this is hard? Can you see this is, for example, I'm going to 61. Can you see this one? So this is 365. Let's decode 365 here. Can you see this is showing police? So where it has written police, you can go back here. The first word is police here, and first word is police here, and first 365 is representing police, which means everything here 555 representing padding, and these words are defining in these large numbers only. So this is how you can define your text in a different embedding format. Now once we have decoded everything, we can check the train data set. You can check the train data set also. You can see this is all the terms, and this is all the token types, and here I want to check the attention mask as well. Can you see this is showing the attention mask everything? Okay, let's see what is the small train data set and upper train data set. I'm going to define this data set only. So this is the tokenized data set, and I'm going to define this shuffle. I'm going to shuffling everything because I do not need this entire data set. I'll have to shuffle for my better accuracy. Now let's use for fine tuning our model. So how to fine tune? I'll have to use my model keyword for my XLNet sequence model, which can load XLNet model with sequence classification or regression, head on top or a linear layer on top of the pulled output, for example for multi-document classification task. So this is model just imported in our portal. The model name is XLNet base cased, and here are 4 labels which we are working on. I'm going to create a matrix for my evaluating model. I'm going to use this evaluate model for my accuracy only. I am going to define a compute matrix for the evaluation value. So this would be the prediction part, and all the accelerating parts are there. I have already included these accelerated and upgrade accelerated, which will be requiring for my upcoming part. So I'm going this will give a quick review for this upcoming cell. If you are having these errors, if you're finding these errors and these errors are throwing on the screen, you can run these cells to upgrade your accelerate library, and then you can continue with the same code. I'm going to run this training arguments. Those are output directory, test trainer, and evaluate strategy, epochs, and number of epochs. I'm going to keep it 1, but you can increase these value with large number for better accuracy. Let's run this trainer keyword for my training purpose only. I'm going to define this trainer ND and going to run this part. If you are, let's allow to train, let's commence this training part, which will be time taking process. Now I'm going to share to you are keen to get started now with fine tuning process, but before this there is a glitch. For example, sometimes if you run this code on a Jupyter library or Colab library, you will have to import API key by clicking on this website. So I'll let you know that you will have to first Google account, follow the instruction and copy key from the first page only. So this will allow you to import that library from that code, and then you can access this trainer and XLNet everything from the scratch. So this will help you learn how to create a trainer module for your fine tuning. What exactly you are fine tuning? You are fine tuning this model which is defined above. Okay, so I'm going to defining XLNet base case model. This model I have trained to which? To my 4 classes. So my 4 classes might be joy, might be anger, okay, might be sadness, okay, or might be another 4th one. So these are 4 library, 4 classes you can see. So what are these? So these are joy and fear, you can say. Okay, so these 4 classes are there for my further values. So fear are just defined here, 1, 2, 3, 4. So I have trained my model for these 4 classes. So once it is trained, you can go back and you can check the accuracy for this. Can you see it's still taking much time and it's still taking training part? Why? Because this is training our predefined module with the certain epochs, validation loss and training loss. Okay, once it is trained, we can check the evaluation model as well. So let's see, let's run this cell. I'm not going to run this cell, so but it is just writing here. Can you see it's still training and checking the accuracy for this one? Okay, now what we have done, revise here. I'm going to fine tune over my sequence classification. If you are having any other classification, you will have to use another format of this model. So this is the approach of using fine tuning model from your custom data, for your custom data only. So these custom data is having only 4 classes. So I'm going to define all these number of classes here, and XLNet base class I'm going to use here. Can you see this is now just completed? And let's run this trainer.evaluate. What's the accuracy there? And of course the accuracy would be very low because this is this just run for only 1 class only. Let's save this once it is completed. I'll save this model and then I can reuse my model for the from the given fine tune, and I can use this pre-train model also from my text classification, and then I can run the same integer number for the given integer number, and let's check what would be the output there. Can you see this is just showing all the accuracy there? Once it is completed, I can save this model. This would be saved in my local machine, and then I'm going to fine tune my pre-trained fine tune model, and then I'm going to use this model, and now I'm going to run this model here. Can you see this is just running, and ignore this these warnings, and you can see this is the sentence. and this text is just checking the sentiment. Can you see first label is what? First label is joy and the score is this value. This label is fear, second label is fear, the score is 27.3%. This score is 39%. And what is the third label? This label is sadness and the score is 70% for sadness there. And then what's the fourth label there? Anger. So anger is what? Anger is 16%. Okay, let's see which is the highest one. The joy is the highest one. So label 1, joy is the highest one. So let's check the sentence here. Mom, you remember when when nearly died, you cried like a baby. This is joy and this is the sadness, and this is not the correct answer. But if you run the same cell, you will have to check the same values. Okay, so I'm going to check the another one. Can you see? At least blank, Lively and Rain Reynolds are still together. God bless that Bennet's couples. Can you see? It's showing 29%, score 27%, and sadness and everything there. You can check this value by defining relevant score for the given text. This would be sentiment analysis, and once it is defining highest score, you can discuss this portal. This is going to cover the advanced activity of this converting process from the normal text to embedding system, and then finding the sentiment analysis for the same. This is how we can perform fine tuning for the same. Thank you so much. Keep learning, keep growing.